So we are doing identities now, and of course you did your exercise 5 now, and you can have your pencil and mark. So these first 3 are what I'll call the easy ones in the exercise, and the easy ones are always the first ones we talk about. So in this situation, although I would usually take the left hand side and simplify it until it becomes like the right hand side, in this situation I'll change and take actually the right hand side and simplify it until it becomes cos 2x. The reason I did that is that we do have a difference of 2 squares on the right hand side. And so since it's a difference of 2 squares, we ask ourselves, what is it that I squared to get cos to the power of x, 4 of x? So I think you are shouting in your head, it's cos squared x. If you square that one, you should be able to get cos to the power 4. And again, you ask yourself, what do I square to get sine to the power 4? And it is sine squared x. And the other bracket after this is, you just change the sign here. That is what we agreed. That is precisely how you treat the double angle formula, or rather, how you treat the difference of 2 squares. Now, while we have this one, we can see how this part is actually an identity. Everyone knows that that part is actually equal to 1. It's an identity that we remember. And this is one of the expansions of the double angle identities. While we are still at it, why don't I remind you how cos 2x is actually equal to 3 things. Remember, it can be written as cos squared x minus sine squared x, or it could be 2 cos squared x minus 1, or you can have 1 minus 2 sine squared x. So those are the expansions for cos 2x. Let me also just squeeze in sine 2x here in case we're going to need it. It'll be just 2 sine x cos x. So all the time, just have these double angle identities with you until you get used to them. You will then start remembering them from memory. Remember, these are always given to you in the exam. Right, so let's see what we are going to do here. We have already agreed that this is equal to 1, and this right here is a double angle identity for cosine. The very first one, you can see that. So this one will be equal to cos 2 times x, and of course that is equal to our right hand side. That should not be a problem at all. So mark that one in pencil. You should find it very easy to write. Okay, now I said we start with the seemingly easy sums in the question. So I'm seeing how, rather, let's also include 1.3, you know. Let's include 1.3 in our situation. It seems rather simple as well. So I'm going to just put that one in. And look at how we have 1 plus cos x here at the bottom, and then cos 2x here at the bottom as well. It should all be equal to tan x. That is what we have on 1.3, right? Notice, here we started with the right hand side, coming back to the left hand side, but most of the times you'll see that these identities are solved by first of all simplifying the left hand side, the place where there are higher degree of angles. So we want to simplify this until it becomes tan x. But the beauty of this is you have to remember how tan x, so you won't work blindly. Tan x is already known to be sine x over cos x. You know, this is tan x. So what you know is that when you're simplifying the numerator, you have to simplify it in such a way that you have sine only on the numerator, if possible, and simplify it until only cosine is left at the denominator. That is how we do this most of the times. So let's put the left hand side over there. And I think as for the marks for expansion, you should find them very easy to find, especially this one. There's always a mark resting on the double angle for sine. So we expanded the numerator. We didn't even have to switch on our brains to do that. Now this one is 1 plus cos x, But now you have to think a little, because cos 2x, like we are noticing, it has 3 possible expansions, so you have to choose the right one, the one that will simplify your life. And how do you choose? You always ask yourself, what do I need at this time? And at this time, from what I say, you need cosine on the denominator. So you have to choose an expansion that has only cosine, if possible, on the denominator. And as you can see, that will be this expansion right there. So I'm going to write it as 2 cos squared x minus 1. Like I have already indicated at the beginning, these ones are the easy ones, as we are all seeing 1 and 1. You know, good things happen to good people occasionally. So here we are, it's simplifying easily. Now, just when we thought it was going to get difficult, we can see there is a common factor on the numerator, what we really wanted. And at this point, it is sine x that is there on the numerator. We can take it out. There will be 1 left, and here is 2 cos x. Okay, that will be the numerator right there. Sine x is already out. We needed it. And notice at the denominator, there are only 2 terms left. And since there are 2 terms left, they're very simple to factorize. You just have to take a common factor. And in this situation, the highest common factor should be cos x as well. And notice how that would go once there. And if I take one of the cos x, we should be left with just that. And hoo-hoo, look at that. Just get rid of those brackets now. They can easily cancel, and you should have sine x over cos x. And everyone knows how that is equal to tan x. And that is definitely equal to the right-hand side. So, proving this one, I know most of you proved it right, but now you're getting the skill of knowing when to use which double angle and how to use it. So that is the main skill I want you to get. Please notice I'm using a very small board, so you should be very fast in copying. I'm going to erase question 1, but very soon I will be erasing this other one. So if you're still copying, do it in a hurry, please. We are running out of space. Right, I will write another sum in the meantime and make sure that we get ready with it. While you are still fresh about what you're thinking right now, why don't I write 1.6, which is exactly almost similar to 1.3, the way we do it. So notice how that one is now written as sine 2x minus cos x, and it's all over 1 minus cos 2x minus sine x. Everything is over. It's like this. This is what they want us to prove. So just make sure that you have it right over there, and let us prove that one. I would like to believe that you're done copying 1.3. I need all that space to answer this one. But you can pause the video and you can actually work it out or mark it. I think you're already done with this question. Mark it, let's see. I believe you got to the right hand side. With identities, it's very good. If you got the right answer, you would know because the answer is there. You're supposed to get to that. If you fail to get to that, it means you don't have the solution. So here is what we're going to do in this situation. Again, I'll take the left hand side. The custom is you have to rewrite it again, but because of space and time, we have to just quickly simplify. Please sine 2x. That's the easiest guy to handle. Sine 2x is all the time 2 sine x cos x. No stress. And let's put minus cos x over there. I would like to think that you're already looking on the denominator there to see what's what. I'm sure you're thinking of your expansions there. 1 minus. It's very good to think of what to do at times before you do it. Because for cos 2x, you always have to switch on your brain. At this point, you want just sine x to remain. So you're busy thinking to yourself, which one should we change cos 2x to? And you got it right. Yes, we should change to something that has just sign. So I'm going to put 1 minus 2 sine squared x for it. And then we also have that minus sine x, this one right here. Okay, let's simplify that one now. Let's finish it off. So to finish this one off, on the numerator I already see that we have a common factor, but at times you have to just keep going so we can do one thing at a time. I wanted to first of all come here so we can simplify the denominator first. Notice this is, when the negative goes in, this will be 1, this will be 1, minus 1, and this will become positive 2 sine squared. So 1 minus 1 will cancel, but this 2 sine squared x will remain. So we are done with this part, but let's not forget there is minus sine x there as well. Like I said, if there are two terms, you won't have to worry. These are the first few identities we are proving, so you would find they are still very simple to handle, and I can factorize cos x on the numerator. And notice you are still left with 2 sine x here, and that would be minus 1, of course. And at the denominator, notice we also have a common factor, but this time it's a common factor of sine x. So let's take it out, and that should be 2 sine x left as well, and notice that one is minus 1. So if you got that one right, we can simply cancel what's common, and you can see the similarity between these questions, so you should start appreciating a skill here. So far you have the skill of being able to identify which double angle identity to use and at what time. So good. If you got these right, it means that skill is in there. It would just be fair if we also talk about 1.8 because these questions are related. So I'll quickly rush through 1.8 with you just so we can finish this. Since there is a bit of space here, I'm going to force it to fit over here, and it is sine x minus cos 2x. Then we also have sine 2x here minus cos x. Sine x plus 1 over cos x. So we are going to prove this one. I gave you enough time to copy question 1.6 if you were struggling to follow along. So you copied 1.6 so far, so we should be able to prove that one together quickly. So I'm going to erase 1.6 now that you're done copying it, obviously. Please write neatly and make sure that you have all the notes. They will be checked on the first day of school, I am pretty sure. Right, so what do we do? In this situation, you are using the very same skill that I taught you of what to choose and when. Right, let's see if there will be an exception in this one. I think you are already agreeing that we should take the left hand side, and I agree as well. So sine x is very easy to copy down, but now we have to think. On the numerator, we want sine x plus 1 to remain. Since sine x plus 1 is here, you may have to expand cos 2x with mostly sine. So of the 3 expansions you've got, you have to choose the one that has sine on the end numbers, likely. So it would definitely be this third one. So let me write that one down. It's important to put it in brackets since there is a negative sign. You want to make sure that the negative sign affects every term inside there. Okay, sine 2x, you do that one without thinking. It's the only expansion there is, so you can copy that one easily. Then you've got cos x like that. So let us see how this simplifies. As you can see, the numerator now is I'm going to have to rearrange this fast because I don't want to have too many steps. Notice sine x will be here. Let me say this is sine x. This sine x that I wrote is this one. But this is minus 1. Let me write minus 1 there. And then minus times minus 2, it will be positive 2 sine squared x. Notice this was a positive sine x. I think you're seeing why I wanted to write it like this. So, so that it can be a trinomial. You can see it's a trinomial that we can easily solve. So this one was a little bit different to the ones that we had. The ones that we had a few seconds ago were just the ones where there were just two terms and you just have to find the highest common factor, like here, the denominator here. This one is a trinomial. You have to think of factorizing it properly and it should work out very simply afterwards. So now that we know what we want to get, so I will quickly factorize this one. You know the method we use to factorize, so go ahead. You can factorize in your head whichever method you use as long as you are factorizing. So of course we should have to sine x, and then we also have sine x here, and it should be -1 and then +1. That should be the factorization. Remember, you should be able to easily factorize that one. You should also be able to check if you're right, because you don't want to carry on with incorrect factorization. So in this situation, I'm going to carry on with cos x. Then we also have 2 sine x -1. Beautiful. Notice how this one will cancel. This one and that one, they will cancel to give you what you've been meaning to get all this time. And that is this one, sine x +1 over cos x. Hey, notice how it is exactly equal to the right hand side. So for the first part, I think these 4 should do. You're getting used to your double angle identities, when to use them, and how to use them to prove other identities that we may have. All right, thank you. This will be all for this video.